Chemical control methods. Factors that would affect the efficiency of chemicals would be the initial load, how much bacteria we're actually starting with, the environmental, heat and the presence of organic matter, the amount of time that we leave it exposed to the chemical, the organism, are we dealing with spores versus endospores, because we know, nothing kills endospores except for a autoclave, the mycobacterium and the lipid-rich cell wall, and then gram-negative organisms in the outer membrane. We know that sometimes they shuttle what they want in and out. So, chemical agents, this is a table. Phenols, which are lipid-soluble, disrupt plasma membranes. It's used as a disinfectant, so perfect type of example would be the O-Seal that we use in the lab, as well as Lysol disinfectant. Bisphenols disrupt plasma membranes, and it's used with soap. You usually find a agent called triclosan in your antibiotic soaps. Iodine is a halogen. It alters the protein synthesis in the membranes. So it's an antiseptic. So a perfect example of this would be the betadine antiseptic. Chlorine is enzyme damage, and we use this to treat water. Also the disinfectant. So bleach is a perfect example of this. Alcohol denatures proteins, dissolves lipids, often used to enhance other chemical antiseptics, so rubbing alcohol. Heavy metals denatures proteins. It's also an antiseptic. Silver impregnated dressing, we see these in burn units. They use these on people that have severe burns. And then surfactants, they decrease surface tension, wash away cells. So example of that is soap. Resistance to biocides. This picture shows you the most resistant to least resistant. And of course, at the top of the list is prions. After that, we'll see that it's the endospores. Endospores have that thick spore coat protection. Then comes mycobacteria that have a lipid-rich cell wall. Then you have your gram-negative bacteria that have that LPS and porine protein. So remember the LPS, the lipopolysaccharide, and the outer membrane with those selective porins. And like we said before, it's real easy to kill gram-positive bacteria. This is a picture showing you the resistance to biocides. And again, gram-positive versus gram-negatives. And you can see in this one, gram-negative, it's really, Pseudomonas is really resistant to a lot of different biocides. E. coli, I could go a little bit to chlorine. You can actually see the resistance there. And then, of course, we see a lot more, not resistance, but a lot more susceptibility here. And then you see a lot more susceptibility here with Staphylococcus aureus. Here ends Chapter 4.